All right, let's get right into it. Today, we're digging into a cosmic detective story that could literally rewrite our understanding of how the universe ends. The big mystery we're trying to crack is this. Is that weird, invisible force that's pushing everything apart actually starting to fizzle out?
So, just to set the stage, think about this for a second. The vast majority of our universe is made of something we call dark energy. And honestly, we know almost nothing about it. We have no clue what it is, where it came from, or really, how it works. For decades, we've basically been banking on one big idea about this mysterious force. But what if that idea, the very foundation of our model of the cosmos, is totally wrong? What if it's starting to crack? Okay, so to really get why this new clue is such a potential game changer, we first have to talk about the official rulebook. The model scientists have been trusting for more than 25 years to explain, well, everything.
It's called the Lambda-CDM model, and it's been fantastically successful. That lambda symbol you see, that stands for dark energy. And for a long time, it's been the neatest, simplest way to explain why the universe's expansion is actually speeding up.
Now, what's so wild about this chart is what it says about us. See that tiny little 5% sliver? That's what we call normal matter. That's everything we see and touch. Stars, planets, you, me, all of it. The other 95%? A total black box. And here is the absolute bedrock assumption of that whole lambda model. For a quarter of a century, physicists have treated dark energy as a constant. You can think of it like a steady, relentless pressure that's been pushing the universe apart faster and faster since the beginning of time, never changing.
But what if it's not constant? Well, a brand new experiment just dropped a clue that challenges that entire idea.
Meet the Dark Energy Spectroscopic Instrument, or DESI for short. This thing is the ultimate cosmic mapmaker. It's a seriously advanced piece of kit that can look at 5,000 galaxies at the same time, building this unbelievably detailed 3D map of the universe's history.
And after crunching the numbers from just its first year of data, the DESI team dropped this bombshell. The data hints that dark energy isn't constant at all. In fact, it might actually be getting weaker over time.
So, how solid is this? Well, in physics, you need what's called a 5 sigma result to claim a discovery. That means there's only a 1 in 3.5 million chance you're wrong. DESI's results, they're hovering around 4 sigma. That's very interesting, but it's not quite a slam dunk. Not yet.
Okay, and this is where our detective story starts to get really complicated. Because it turns out, the strength of this clue from DESI completely depends on what other evidence you look at alongside it.
The key witnesses in this investigation are something called Type A supernovae. Basically, they're exploding stars that always go off with pretty much the exact same brightness. They're like cosmic lighthouses. By seeing how dim they look from Earth, we can figure out how far away they are, which is perfect for mapping out cosmic expansion.
So here's the twist. The DESI team took their map and combined it with data from these supernova lighthouses. The problem is they used 2 different catalogs of supernova, and those 2 catalogs told 2 completely different stories.
And this right here, this is the heart of the whole problem. When you pair DESI's data with one supernova set called Pantheon Plus, the hint of changing dark energy is pretty weak, only about 2.5 sigma. But when you use the other set, called DESI 5Y, the signal shoots up to 3.9 sigma. That's a huge hint that our standard model is broken. We have conflicting testimony from our key witnesses.
So what gives? One set of clues points to a revolution, the other points to business as usual. It all leads to the biggest question in this whole investigation. Is this clue real, or is the evidence somehow tainted?
I mean, could this entire massive cosmic drama all boil down to just a simple mistake? Scientists have a name for this. They call them systematic errors. They're these subtle little glitches in how we measure things that can trick us into thinking we found something real.
And the prime suspect in this case might just be this one unbelievably tiny number, 0.04 magnitudes. It turns out there might be a measurement error this small when you compare the brightness of supernova that are close to us versus ones that are very far away.
I mean, an error that small is like a tiny, faint smudge on a detective's magnifying glass. It's so small you'd barely notice it, but it's just enough to warp the picture and make you see something that isn't actually there. It could be creating a phantom in the data.
And that's not the only possible culprit.
There's a whole lineup of these potential errors. Things like how we calibrate our telescope images, how cosmic dust might have changed over billions of years, even how the stars themselves might have evolved. Any one of these could be throwing off the entire investigation.
So after looking at all the conflicting testimony and the very real possibility of tainted evidence, where does that leave our cosmic case?
Well, this might just be the smoking gun. When scientists rerun the numbers and correct for that tiny 0.04 magnitude difference, you know when they metaphorically wipe the smudge off the magnifying glass? That dramatic evidence from the DES 5Y dataset, it just vanishes. The data snaps right back into place, perfectly consistent with the standard model where dark energy is constant.
Which leaves us standing at a huge fork in the road. On one path, we could be on the brink of a revolution, discovering that dark energy is alive and changing, which would totally alter the fate of our universe. On the other path, this is a profound lesson in just how hard science is, a cautionary tale about the incredible challenge of measuring the cosmos with the precision we need.
As DESI keeps on mapping millions more galaxies, this case is definitely still open. The hunt for the truth goes on, and it leaves us all wondering, are we about to finally crack one of the universe's biggest secrets? Or are we just getting a masterclass in how incredibly hard it is to be sure of anything at all?